All right, so now we're going to talk about percent change. And so basically we have please tell me we're going to start writing. All right. Basically we're going to take our amount, maybe, of increase or decrease. So you normally are going to get that by subtracting to get how much did we increase or decrease by. And we're going to divide that by the original amount. What is kind of missing from this, because this says is equal to the percent, we should technically take this times 100, and then that equals our percent change. The equation in the book didn't have the times 100 piece, but to make it a percent, we need to. All right, so what does that look like? All right, so we have a coat is on sale. The original price of the coat is $82, right? So that's original amount. And the sales price is $74.50. What is the discount expressed as a percent change? And so we are technically doing the absolute value, but really, as long as you just take your original minus the sale amount, and then in the end, we're going to divide that by our original amount. So 82 minus 74.50 is going to give us 7.5. So we decreased by $7.50, and we're going to now divide that by the $82. And so when I take 7.5 divided by 82, I get approximately 0.09. I'm saying approximate because I am rounding my decimal. And so when I round, it becomes an approximation. Now this 0.09, when I take that times 100 or make it into a percent, would be 9%. So we have a 9% change. Or in other words, the discount was 9%. But when we talk about it as a percent of change, it was a 9% change. Done. All right. Next one. A store buys an electric guitar for $295, so that's our original amount. The store then marks it up, which means, adds more to it, the price to $340. What is the markup expressed as a percent of change? So on this one, I'm going to take the 340 minus the 295 because that's what's going to give me a positive number. And then we're going to divide that by 340. Oh, 340 wasn't the original. Silly Miss Cartwright. We got to divide that by the original, not the markup. And so divide by the original, that's 295. From here, 340 minus 295 is going to give us a markup of $45. So they added $45 to the original price of the guitar. We're going to take that 45 divided by 295, which will give us approximately 0.15. So that's it expressed as a decimal. Then we express it as a percent. That means we move our decimal 2 places. And so it was a 15% markup. And so that is our percent of change. Our price changed by 15%. Now, on the same thought, when we talk about relative error, so our relative error or otherwise known as our percent error is going to be equal to, I'm putting this one in absolute value, the measured / estimated value minus the actual value. And again, that's absolute value of that, so that means that basically positive, our distance from 0, and we will divide that by our actual value. So relative error, we're finding like what we measured / estimated, and we're going to subtract the actual value and then divide by that actual value, and then that gives us our percent of error. So what does that look like? Here we have a decorator estimated that a rectangular rug is 5 feet by 8 feet, and the rug is actually 4 feet by 8 feet. What is the percent error? So our estimated, right, area, so for a rectangle, base times height, or length times width. So our estimated value is going to be 5 times 8, which is 40. And our actual value is going to be 4 times 8, which is 32. So now we're going to take those two and I'm going to plug them in. My measured or estimated, our estimated minus our actual divided by the actual. So 40 minus 32 is 8. And then we're going to divide that by 32. So we end up with 0.25 as our decimal, because 8 divided by 32 is 0.25. There is no approximately here because that is a terminating decimal, meaning that it ended. And then when I write that, so this is our, not percent error, this is our relative error is 0.25, but then our percent error would be 25%. So there was an error in our area by 25%. All right, next one. You are framing a poster and measure the length of a poster as 18.5 inches to the nearest ½ inch. What are the minimum and maximum possible lengths of the poster? All right, so when we're talking about possible error, the greatest possible error is half of what you've measured to. And by measure to, I'm meaning, here we're saying we're measuring to the nearest ½ inch. So half of ½ an inch would be 0.25, so 1/4 of an inch. So for our problem here, our greatest possible error is 0.25. If we're rounding to the nearest, or measuring to the nearest inch, then our greatest possible error is going to be 0.5, because when you think about it, if I'm rounding to the nearest inch and I'm over halfway, then I'm going to round up. But if I'm below the halfway, I'm going to round down. And so the greatest possible error we're going to have is whatever is half of what we are measuring to. So in the case of this problem where we're measuring to the nearest ½ inch, our greatest possible error is 0.25. So what I'm going to do is I'm going to take, so for my minimum length, I'm going to take my measured minus the possible error. So in this case, my measured is 18.5 and my possible error is 0.25. And so I end up with 18.25 as my minimum length that this could be. And then for my max length, I'm going to take the measured and I'm going to add my possible error. And so now we have 18.5 because that's the measured, and I'm going to add 0.25, and so now we end up with 18.75. And so those are our two answers. Our minimum possible length is 18.25, and our maximum possible length is 18.75. And so it just asks what are the minimum and maximal possible lengths for this poster. And so that's what the minimum and maximum possible lengths are. We're just minimum, we're going to subtract what is half of our measure, what we're measuring to the nearest of, and max we are going to add. So now putting that into play, we have a gift box that has a length of 12 inches, a width of 6 inches, and a height of 5 inches. What is the greatest possible percent error in calculating the volume of the gift box? So first off, volume equals length times width times height. Just so we get that out of the way. So possible error, because all of these are measured to the whole inch, our possible error is going to be 0.5, because that is half of a full inch. And so starting with measured, I'm going to find that the volume is the length, which is 12, times the width, which is 6, times the height, which is 5. And so when I do that multiplication, 12 times 6 times 5, we get 360. And now I'm going to do my minimum. And so to find my minimum, I'm going to do 12 minus 0.5. So that's going to give me my 11.5. I'm going to do 6 minus 0.5. So now I'm at 5.5. And I'm going to take 5 minus 0.5. So now I'm at 4.5. And so now when I multiply 11.5 times 5.5 times 4.5, I end up with 284.625. And so that is the volume for my minimum, if they are all the minimum value. And my maximum, I'm going to add. So 12 plus 0.5 is going to be 12.5. 6 plus 0.5 is going to be 6.5. And 5 plus 0.5 is going to be 5.5. And then I multiply all those together, and we end up with 446.875. So that's my first step. These are all of the values, the way it's measured, my minimum volume and my maximum volume. And now I need to find which one has the greatest percent error. And so we're going to start by subtracting, and I'm going to take my actual minus my minimum, 284.625, and that's going to give me 75.375. And then I'm going to do my maximum, 446.875 minus 360. Oops, not parentheses. I want my absolute value bar. And that gives me 86.875. So if we're wanting to find the greatest possible percent error, then I don't need to figure it for both of these. I just need to do it for the biggest one. And so the biggest change is for the maximum. And so now I'm going to take 86.875 and I'm going to divide it by the actual, which is 360, or the measured. And so then I get approximately 0.24 because I rounded. And then 0.24 as a percent is 24%. And so that is the maximum percent possible error. And yes, that's a lot of work. But that's how, when people are calculating errors, this is what they're doing. And this is how they calculate like our errors in MAP, etc., is they do stuff like this. All right, that is it. That was pretty long, and I apologize for that. Until next time, 8th graders. Peace.